Assalamualaikum everyone, and today we are going to talk about the types of numbers. So we have to learn the types of numbers, because all numbers aren't just the same type. There are many different types of numbers which we have to learn to understand some things. For that, we have to look at the taxonomy of numbers, like we look at the taxonomy of biological organisms while talking about biology, or in particle physics, the taxonomy of particles or matter for that case. Just like that, we have to look at the taxonomy of numbers. Now, let me show you the types of numbers. As you can see, I'll draw a diagram here while we go throughout the types of numbers in the whole video, so we wouldn't erase the diagram. So the first dividing of the numbers are real and imaginary. Now, real numbers are all the basic numbers we learned about. Pi, 4, 3, basic, all the numbers, -4, -pi, all the things. And imaginary numbers need a little more explaining to do. So remember in my last algebra video, I told this, is that in the quadratic equation, when we have this part, b squared minus 4ac, and if you don't know what the part is, then look way back to the quadratic equation video so that you understand what I'm talking about here. Again, link in the description, or I'll add a link to the video. So here, if the square root is a negative number, this whole combination of b squared minus 4ac, if it's a negative number, there's no real solutions. Well, that is technically true. We have an imaginary number, which is that when something, the sum square root of a negative number. By the way, we're talking about square roots here. In a cube root, there are possibilities of negative numbers being cubed to get some number, because negative times negative times negative is a negative. Anyways, I got sidetracked. But in a square root, there is no real solutions. So we invented this type of number, which is that square root of -1 equals to I, and square root of 1 equals to 1. So the square root of -1 equals to I, and something like square root of -4 will be equal to 2I. This makes sense because the square root of 4 would be 2 times -1, square root of -1, which will be I, so 2I. So that is the imaginary part we're looking here. Again, this is not a real number, so you wouldn't see this number in a number line. Like in variables like pi or e, they will be in some sort of spot in the number line. But this is imaginary. The number line is a set of real numbers, but this is an imaginary number, so we cannot put a specific real value to this imaginary number. I know this is getting confusing, but that's just how confusing imaginary numbers are. The next two types of numbers will be within next two subdivisions or subtypes, whatever you like to call it, of numbers will be within the real part, and that you must have heard before if you, let's say, studied a lot math before. Rational and irrational numbers. Now let me explain this to you for those of you who don't know. You see, any number can be explained in a ratio. Any integer divided by any integer. And 1 can also be in the denominator. The only thing that cannot be in a denominator is 0, because this is very confusing, but let's just say divided by 0, anything divided by 0 is undefined. 0 divided by anything equals to 0, but anything divided by 0 is undefined. You have to know that. Anyways, back to the topic. Here, A over B, which we'll call it, will be some sort of ratio. Now, if we can explain this ratio, this will be a rational value. But something like the square root of 2, which if you plug into a calculator, it will be 1.41421 blah 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 blah, and it keeps going on forever with no pattern, which means that you cannot put it in a specific ratio. Anything that cannot be explained like that or does not have any pattern or anything like that is an irrational number. Now you might be thinking, if this has no pattern and it keeps going on forever, isn't this supposed to be an imaginary number? Because you cannot put a specific place and get an infinitely accurate value, since it kind of goes on forever. Like the square root of 2 can be, let's say, approximated by 665,857 over 470,000 times 832. Okay, that was a lot of numbers, but it's not quite there yet. So isn't this supposed to be an imaginary number, since when you plot a point you don't exactly go there? Well, no, because the square root of 2 is not just any number. It's from a right triangle. When both of the legs are 1, the hypotenuse would be the square root of 2. And in order for square root of 2 to exist, then triangles should exist, which without a doubt triangles exist. I hope we can all agree with that. Another irrational number is, you guessed it, pi. I have a whole video about it. You can go watch it, link in the description. And let me warn you again, this is not the food pi, it's the number pi. Pi is 3.14159 blah 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 blah. And it goes on forever with no pattern. It's just basically the ratio of the circumference to its diameter. Now if you might be thinking, well, if it's a ratio, then it should be a rational number, right? Well, no. You see, the circumference will be an irrational number because of this equation. Pi times the diameter equals to the circumference. Now, since this keeps going on forever and forever and forever, times the diameter means the circumference, or the result, will also go on forever with no pattern, which means that this won't be something like that. Now, isn't pi imaginary? No, because this is something about circles, and circles exist, obviously. the other types of numbers are fractions, whole numbers, then natural numbers, as we call it too, and other things. With that, we have all the things, all the types of numbers done. So, after all that hard work, we finally mastered a very good understanding about numbers. And we also learned about some new numbers like I, and we learned about some things that how numbers work and other things. So that's all there is to it. You can subscribe to my channel if you want more math or science help or something like that. And you can also like the video. You can comment down below, was this video helpful, or what you thought of the video. So thank you for watching, and I will see you next time. Bye.